So what I'm going to be talking about today is mind uploading, brain copying, conscious computers, etc. And I'll start off by talking about the problems. First is just assuming that these things are inherently, inevitably possible, and it's just a question of mere technological challenge. We have very little evidence that, or no evidence that they are inherently possible. Or that they're mere technological challenges. Another problem is assuming that consciousness is algorithmic and that the brain is nothing more than a processor or some sort of a general purpose computer. Of course, Roger Penrose is famous for giving his argument as to why consciousness is not algorithmic and maybe not computable. But I would say in general, maybe it's safe to say that most scientists just assume that consciousness just necessarily is the result of computation in a computer, but that's an assumption. Another assumption is just assuming that a conscious state can be copied or repeated. I think that if you asked a random scientist or physicist, can you copy a brain? They would say, well, in principle, yes. And I think that's just an assumption that's not founded by evidence. Scott Aronson is a computer scientist at University of Texas at Austin, who wrote a paper that I cited at the end of this in references. And he argues that, well, maybe it's not copyable, and he gives a reason for that, but he kind of tiptoes around it a little bit. But in general, I think that is assumed. And then another assumption that may be problematic is that quantum mechanics is irrelevant to consciousness. I think a lot of people might think, well, consciousness is kind of, it probably is a macroscopic thing, and, macroscopic entities can be modeled classically. We don't have any evidence that it's a quantum mechanical, and plus the brain is hot and it's wet, and we can't maintain quantum superpositions for more than, 10 to the minus 10th seconds or something like that in the brain. Again, Rose and Hameroff are arguing the other way, but nevertheless, I think many people think that quantum mechanics is just irrelevant to consciousness. Well, that's just false, demonstratably false. Just with a simple example, somebody is walking around with a Geiger counter and aims it at a radioactive substance. Whether or not that person hears a click in a given time period is, of course, a quantum event. And whether or not the person hears or experiences hearing a click is, of course, two different conscious states that are correlated to some quantum event. So it has to be the case that quantum mechanics enters into the picture somewhere. It may not be in the brain proper, but just to say that quantum mechanics is irrelevant to consciousness is false, and it's an unfounded assumption. Now, because of all these assumptions, there are lots of problems. They're all kind of the same problem, but they're all interesting. So I'll mention them briefly. One of them is the duplication or teleportation problem. And it just, what if I want to teleport myself to Mars? And so the way we've done it is somebody scans my brain, or whatever happens, whatever physical system creates my consciousness, scans it, and then recreates the exact identical state on Mars, and at the same time destroys or kills the instantiation on Earth, then that would seem like I would blink and find myself on Mars. That's teleportation. But what happens if the person on Earth who was supposed to destroy me or destroy this physical state isn't doing their job, and now there are two instantiations? The question is, well, what do I experience? Do I experience remaining on Earth, or do I experience being on Mars? So that was a problem presented by Penrose in The Emperor's New Mind. Another problem is the simulation problem. Nick Bostrom says, well, if consciousness is algorithmic, the cost of creating a computer program, especially with Moore's law, is very low versus the cost of actually creating the physical system that produces my consciousness. So if consciousness is algorithmic and I can upload that to a computer, well, then it's so easy to copy that the ratio, the cost of producing an actual physical conscious me, well, they're all physical, but an actual silicon carbon blood-based me and a digital computer me, that ratio is, you know, infinity to 1 essentially. And so the likelihood then that I am actually real, or that I'm actually a body, is essentially 0, because the chances are almost 100% that I am a simulation, I am a copy running. So that's kind of an interesting philosophical problem. Another problem that arises, Adam Elga at Princeton, a philosopher again, gives this idea of self-location. So he says, Dr. Evil contacts you and says, look, I have made 1,000 copies of you, and in fact, you happen to be one of those, and if you don't give me $1 billion, then I'm going to torture all of these 1,000 or million copies. And so Elga says, well, since you can't tell which one is the real you, since you can't locate yourself, you should assume that there is an extremely high probability that you are one of the copies and you don't want to be tortured, therefore you should pay Dr. Evil the money. So that's the problem of self-location. And then another problem, among others, is the Boltzmann brain, the idea that anything that is not forbidden by quantum mechanics is mandatory, will happen given enough time and space. And so the idea of the Boltzmann brain is simply that, well, whatever it is that creates my conscious awareness right now, let's say it is my brain, and my brain is made up of carbon and silicon and nitrogen and et cetera. Those atoms do exist in free space with very, very low density, but given enough time, some of them will come together in just the right way that will produce my brain, or that physical state that produces my consciousness. And so what would it be like? I could be dead and gone, and then, you know, 10 billion years from now, suddenly my brain just appears magically in outer space. What would it be like to experience that? So it's interesting that these problems and lots of other problems all arise from these assumptions, and yet, and maybe I'm being too broad here, but I really think that the vast majority of physicists and scientists in general would assume these various things and just say, well, okay, yeah, there are problems that result from that. We'll have to solve those problems, but it's still true. Obviously, you can copy a brain. So I'm going to challenge that as I move forward. So the two assumptions that I'm going to make are, first of all, physicalism. That word gets tossed around, but I'll be very specific. What I mean simply is that a given conscious state supervenes on or is entirely dependent on some underlying physical state. And that is to say that there's some state S1 that is sufficient to create a conscious state C1. Now, you might be able to make it even smaller than that, but the point is, I'm going to assume that there is some, oh, and here's my picture, Einstein playing a violin. So I'm just going to assume that there is some physical state that you can kind of wrap around a cloud, some hypothetical cloud around, that would produce Einstein's conscious state at that moment. Again, it could be smaller than that. Maybe you don't need everything in Einstein's brain. Maybe you just need certain neural connections or certain atoms, but that there is some way to at least encapsulate that physical state to produce that consciousness. Now, how big is that physical state? Does it include the violin or other things or other parts of his body? Does it include the room? Does it include other things in the universe? I don't know, and it's kind of irrelevant. All that matters is, for physicalism, is just simply that there is some physical state that I can encapsulate that if copied would produce the exact same conscious state. And do I mean a classical state or quantum state? Again, it doesn't really matter. The point is, independent of our knowledge, the point is that there, if physicalism is true, there has to be some physical, something about the universe that produces that conscious state. So that's my first assumption. The second assumption, oh, I'm sorry, I have to move the thing right here so that I can see my own presentation. Okay. The second one is copyability. So I'm going to assume that that physical state S1 can be copied or repeated in some manner that does not prevent any other copies or instantiations from evolving. I'm going to talk about this a little bit later, but we have to be aware of the quantum no cloning theorem. I'll get to that in just a little bit. And so what I'm going to do is I'm going to analyze these two assumptions from the position of, specifically from special relativity. So here's what I'm going to do. I'm going to start with some, and I called it a state C1, a conscious state. I'm being a little bit sloppy because really what I've wrapped around is the state S1 that produces the conscious state C1. But for the moment, let's just say that I have that physical state. And what I'm going to do is I'm going to put a light cone around here. So in other words, I'm sure you all know this, but I'll just say it explicitly anyway. Whatever is inside the light cone is timelike. That is, that there is a temporal relationship between those events. Whatever's on the outside of that light cone represents space-like events, and so there is no reality of simultaneity between events that happen this event and then events that happen outside the light cone. So the first thing I'm going to do is I'm going to consider space-like events. So what I'm going to do is whatever creates that conscious state C1, I'm going to measure it, but I'm going to destroy it. I'm going to take all those pieces apart. And for the sake of simplicity, let's just assume that that is the brain. Now, it may not be the case, but let's just assume it's the brain. So we're going to take apart the brain corresponding to C1, and then some later time in space-time, we're going to put it back together. And then that system, that conscious state would then evolve to some, say later, conscious state C2. And then, now I've got a light cone around event C1, and now I'm going to make another copy of that same state and produce C1 notice that both of these events, can you see my pointer? Ken, can you see that?
Yes, yes, I have my mic muted, so it took me a minute to unmute it, but yeah, I can see you here.
Okay, so that event, both of these events are downwind of this event right here, but notice that they are space-like to each other. So now let's say that that conscious state then evolves into the same conscious state C2. So the question then becomes, well, what does this person experience as their brain is disassembled here, and then copies of that brain are reassembled there? Well, I don't think it's difficult to imagine that that person then just experiences a stream of consciousness going from C1 to C2. There's no contradiction here. There's no problem in trying to decide which stream that this person experiences. And it doesn't change if, for example, we create the copy right here and then instantly kill it or destroy it. That doesn't change what the person experiences. That person still experiences a stream of consciousness flowing from C1 to C2. Now, what about this time difference here? Well, that might be some sort of a blip. You know, the brain is taken apart and put back together here. That person may not have known that, a million years have passed between these two. but the person will still experience that stream going from C1 to C2. Now here's the problem. What if that first, well, I don't know, what if this instantiation right here evolves, and due to some quantum event, it does not evolve into conscious state C2, but rather some different conscious state. I call it C2 prime, it could be C3, but the point is that there's some quantum event that differentiates these two. The question then becomes, well, what does the person actually experience? So there's only three possibilities. It's either neither, both, or one or the other, right? And so if the answer is none of those, then we know we have a problem. Well, let's consider neither. So let's say that right when this happens right here, this quantum event happens, it throws a wrench in the whole system, and it kills, somehow it kills the person, and that neither stream of consciousness is now possible. Well, you might see where this is going. That's not possible because this event is outside of the light cone of this entire stream. So there's no way for the information of this quantum change to have reached this. And so there's no way for that to have prevented this from happening. So it can't be neither. What about both? I mean, I don't know what it's like to experience two differing streams of consciousness. I have no proof that it's not possible, but let's just assume, okay, so maybe the person experiences both. Well, a conscious state, because of physicalism, we have assumed that that conscious state depends on that underlying physical state. So in other words, whatever conscious state is being experienced here depends on that underlying physical state, and this depends on that underlying physical state. Well, again, you can see that there's no way for this person to experience both streams of consciousness, since this event and series of events is outside of this light cone, and vice versa. So there's no way for the person to experience both streams of consciousness. So it can't be both. And so, okay, so then it has to be one or the other. But now the question becomes, if it is one or the other, so in other words, if the person experiences so some sort of stream of consciousness that goes from here to here and not this one, or vice versa, that means nature has to choose. But the problem with that is we've already assumed that S1 is sufficient to create that conscious state C1, which means if indeed these are both created by state S1, they have to be identical in every possible way. So there's nothing physical to distinguish these two. So that's not possible. So if there is something that distinguishes these, maybe you say, oh, okay, Andrew, it's simple. Whichever one is closer to the original event in space-time is the one that gets instantiated. Well, that's an additional fact about the universe that extends beyond the S1, and therefore that violates the first assumption that we already have enough information physically to determine those. So in other words, there's just no way for nature to choose between these two possibilities. So it can't be that. Okay, so when we analyze these events from these two space-like events, we run into a contradiction. What about if we look at the same sort of scenario, but from a time-like perspective? So we're going to do the same sort of thing here. We're going to kill C1 and then create C1 here. You know, and again, it evolves into C2, no problem. Here's the light cone here. This time, we're going to create a second copy within the light cone of that first copy so that there is a temporal order between these two. And maybe that then evolves into some C2. And then you can ask the question, well, what does this person, C1, experience as their brain is disassembled, and then a copy is created here, and then a copy is created here? Well, that person experiences the stream of consciousness from C1 to C2. No problem, because there's no contradiction. There's no problem. Of course, now you see where this is going. Even if we kill that there, there's no problem with the person experiencing C1 to C2. But then what happens if some quantum event causes a change so that this now goes to C2 prime or C3? We can ask the same sets of questions, and that is, what does the person actually experience? Well, we could say it's neither. So in other words, this change, this quantum event, basically prevented the person from experiencing any stream of consciousness. But the problem with that is that that whether or not it's neither depends on whether or not this happens in the future. So in other words, if this didn't happen, why would this kill the conscious, the stream of consciousness? So in other words, whether or not it's neither depends on some later event that hasn't even happened yet. So unless we're okay with backward causation, then it can't be neither. Well, then we say, okay, maybe it's both events. And so what's interesting about this is that, you know, every conscious experience you have always has this sense of now. So this person at C1, or at this point right here, thinks it's now. And the same person thinks it's now. And the same person thinks it's now, right? Every conscious moment has with it this weird experience that it happens to be right now. So that means that these two moments must be subjectively experienced as the same moment. But again, what is it like to experience two diverging streams of consciousness that both have the subjective experience of now, if this event hasn't even happened by the time this event has changed? So again, we have the problem of backward causation, so it can't be both. And then finally, we get back to the issue, okay, so it has to be one or the other. But that must mean that there is some information that creates a conscious awareness or a stream of consciousness that exceeds the S1, which we've already assumed from the first assumption. That can't be the case. So we have a contradiction in both cases. So what does that contradiction lead us to? It leads us to the fact that assumption 2 is false. That is, it's not possible to copy a conscious state in a way that all copies of that conscious state could evolve freely. Now, it also might be true that physicalism, the assumption 1, might also be false, but since assumption 2 depended on assumption 1, at the very least, we know that assumption 2 has to be false. So what are the consequences of this? So some of the consequences, and I've kind of just written this out in different ways. So one way to say it would be, well, a conscious state simply cannot be copied or repeated unless there's something about the universe that prevents copies from evolving differently. Another way you could say it is, if two instances of the same conscious state could evolve to different conscious states, they cannot both exist. And then a third way of saying it, which I've been kind of toying around with, is by introducing it as a theorem, which I've called the single stream of consciousness theorem, which says that a conscious entity cannot experience more than one stream of consciousness from a given conscious state. The problem I've kind of found with this is it almost feels like I'm then required to define what a stream of consciousness is. I'm not. All I have to say is, if a person is conscious and that person experiences a stream of consciousness, that person cannot experience more than one. But I don't know that if it's worth adding that phrase, stream of consciousness, in it. But in any event, if I'm right, if you cannot copy a conscious state, the question would be, as a physicist, I would ask, why? What might be a physical explanation for this? So here are some possible explanatory hypotheses. One possibility is that, well, there's simply no way to adequately measure a physical state. It's just not possible to measure a physical state S1 that produces a conscious state C1. So you can't copy it. There's no way to measure it. And the underlying physical explanations might be things like perhaps some of the information is contained in distant particles or photons that are streaming away at the speed of light. You can't catch up to them. You can't measure them. And that may involve some quantum entanglement. But the point is, you can't get that information. That may be one explanation. Another possibility is that measuring the information necessary, necessary to create state S1 inherently destroys it. And of course, that might be because there is a reduction of a wave function, and then we lose out on that quantum information. Another example might be the information has to be measured in a way that to a precision that exceeds what is allowed by quantum uncertainty. That could be another reason. And these are I'm just throwing these out as possibilities. Another possibility is, okay, there is a way in principle to adequately measure the physical state, but it doesn't matter because there's simply no way to actually recreate a physical state. And one example might be, well, okay, we can measure the state, but the state itself, when I showed that picture of Einstein with the cloud around him and his body, maybe that cloud actually had to include, lots and lots of particles that are streaming away from us at the speed of light, or it just may require so much more information that you can't reproduce that physical state. Another example might be maybe S1 is just too big. Certainly if S1 is the entire universe, then we have a good explanation for why we can't recreate a conscious state. But even if it's less than the universe, maybe there's just something about it that you cannot, state S1 is too large to actually copy. Another example might be because state S1 is itself history dependent. Now, it looks like I've got a few additional minutes, so I'm gonna briefly touch on this in a moment. But if S1 is history dependent, and it results that every conscious state itself is history dependent, well, then that just means you can't create a conscious state without having produced all of the conscious states that preceded. So that's an area that I'm currently working on. So I think one thing that's interesting about this is that a lot of people, whenever they're thinking about consciousness, they want to start with quantum mechanics and somehow feed quantum mechanics or relativity into the analysis of consciousness. But actually what I've done here is just the opposite. I've just looked at consciousness itself and looked at it from the point of view of special relativity. And from that, realize that if a conscious state can't be copied in such a way that multiple copies can exist and evolve on their own, it's interesting to note that there is a physical mechanism known that is exactly comparable, and it happens to be quantum no cloning. And it just seems odd that quantum mechanics would happen to fall out of this analysis. So quantum no cloning is simply that you cannot create more than a single copy of an existing quantum state. So you can take a quantum state and then essentially kill it and reproduce that same conscious state, but you can't measure it and then copy it because the measurement itself kills the quantum information. There's more aspects of quantum no cloning, but it is interesting, I think, that this is very comparable to quantum no cloning. So now I'm going to talk about, so why is it then that consciousness cannot be algorithmic? Well, an algorithm is nothing more than some deterministic set of instructions. It takes an input and turns it into an output. Another feature of an algorithm is that it is easily copied. Software can be reset on a computer. It can be executed on different computers. You can take Tinker Toys, right, the right number of Tinker Toys, and then put in some input and then have it process a particular algorithm and give it an output. And so anyway, so we know that software can easily be copied. But because consciousness depends on quantum events that are random, any algorithmic consciousness would necessarily allow two or more copies of the same initial conscious state to evolve into different conscious states. And that is not possible. Another way of saying it is that if a conscious state cannot itself be copied, but we know that an algorithm can be copied ad infinitum, then an algorithm cannot produce a conscious state. Well, consciousness being algorithmic was the assumption that leads to the possibility of mind uploading, brain copying, and conscious computers, and therefore those are impossible. So I've got a few more minutes, and I hope I've been talking too fast. I'm certainly willing to go back and discuss anything. But something I'm currently working on is this question of, are conscious states themselves history dependent? And the reason that matters is it possible just to recreate, well, actually, let me just move on with the slide. Here's an example. So there's some glitch in an iOS computer that has the effect that a quantum event has the following two possible results. Okay, so poor Bob the taxpayer, there's just some glitch in an iOS computer. So either he gets a refund check of $1,000 or he gets some threatening letter with a demand for $1,000. Now, at the moment that he reads the letter, his conscious state indeed becomes correlated to event A or B. So I don't know what he's going to experience. I assume that his conscious state CA is going to be, excitement. I just got $1,000. And conscious state CB is going to be anger or fear or something that he now owes money. But the point is that whatever conscious state he experiences is in fact going to be correlated to some quantum event elsewhere in the world. And just as a note, correlation does not, of a conscious state, doesn't necessarily mean recognizing or remembering a particular event. It simply means that there are different paths that are taken. The conscious state goes in different paths, and those different paths are correlated to the original quantum event. And so the question that I want to ask is, and I want to answer, do all future conscious states remain correlated to that event A or B? And so there's a sort of a silly example I give right here, and that is, okay, so at the moment of opening the letter, if it's event A and he realizes he just got $1,000, he realizes his windfall, and then conscious state B is when he first realizes his loss. How might A potentially evolve in time? Well, maybe he's excited, he calls his mother, and then lots of other things. He drives to the bank. On the way to the bank, he gets in a car accident. He gets sued, he loses his house and savings. As a result, he starts writing country music and he wins a Grammy. Whereas in the case of B, his conscious state is such that he realizes his loss, he shouts angrily, he punches a hole in the wall. Behind the wall, he finds hidden treasure. It allows him to invest in space tourism. He launches himself to Mars, and then he gets radiation sickness. All right, so a very wacky set of events. But the question I want to ask is, could those two events, now remember, at the moment that he wins the Grammy up here, he may have completely forgotten about the original $1,000 he got from the IRS. And in this possible world where he gets radiation sickness, he may have forgotten that he owed $1,000. But it's irrelevant. The point is that these two events are, in fact, correlated to their corresponding quantum event. And the question is, could they actually evolve to the exact same conscious state? Is that possible? And if the answer is it isn't possible for whatever physical reason, then we have a very good answer as to why it is impossible to copy a conscious state. And that is because that conscious state has to be somehow related to its requisite history, that itself, that requisite history is related to quantum events that can't be reproduced. So having said all that, I know I've thrown a lot at you and I really appreciate your attention. I'm just gonna kind of go through these. Just in general, there's lots of objections that people might have, definitions. This is an interesting one right here. Some philosophers will say, well, if there are two instances of the same physical state, they may not actually be the same person. And they call that, in philosophy, they're not numerically identical. But this is just a silly objection, because if it's not the same person, then all those objections, all those problems in the beginning just melt away, right? If the original question was, can I teleport myself to Mars by copying my brain? But if the answer is, well, that person, it looks a lot like me, talks a lot like me, but isn't me. If I don't experience going to Mars, well, it's not a problem anymore. So that's not a real objection. Anyway, there's lots of others, many worlds, you know, using physics instead of neurobiology, etc. What I'm gonna do is I'm just gonna go ahead and I guess maybe I'll address them briefly. Why do I want to look at this from a physics perspective? I mean, I think that physics is fundamental. I think that if we can learn things about consciousness from neurobiology, et cetera, that's great. But again, neurobiology is assuming that consciousness is a creation of the brain. And I don't want to assume that is an assumption. We don't know that. If consciousness depends on things that exceed the brain, well, then that's not going to be adequate to understand consciousness. Isn't this just philosophy? No, it's not. I've read tons and tons of philosophy, and I feel like the physicists are the ones that are making the real progress in this. That's just my opinion. Is it pseudoscience? Well, if it's testable and falsifiable, absolutely not. Consciousness is one of the last remaining things, big things that we really don't have a clue about, and I think that it's time the scientists stepped up to the table and really started to address it, which is why I'm so excited about working with you all. Anyway, that's all I've got for now, and then here's the references that I have. Two of these are papers that are currently on the archive. They're being considered for publication right now, but you can look them up. But anyway, so that said, I would love to hear any questions or comments that you have.